All right, so I'm going to quickly share my screen and see.
This call is now being recorded. This call is now being transcribed. This call is now taking notes.
All right. Okay, is my screen visible? Okay, I think it is. Is my screen visible? Can you see it? Just an emoji will be fine, or put in the chat box, say no or yes. Okay, Cynthia can see my screen. And for some reason, I can't see mine. Okay. Let's see what we're going to be looking at here. Okay, so if you can see my screen, I don't know, can you see my Word document? I'm using two devices. I can't see it on the other one, so I would need confirmation. Please unmute yourself. Cynthia, please unmute yourself and tell me if you can see my Word document. Anyone?
Yes,
You can see the Word document?
Yeah.
Okay, what are you seeing? SED 232, right?
Yes, integrated science special methods.
Oh, okay, thank you. Thank you. I can't see it on my other device, so it's a little confusing. Okay, so I wanted this to be a short class, like I said earlier, but for some reason I keep adding and adding things to the notes and I can't seem to find what to remove. So, but we're going to be a little fast. Okay, I can see it now. We're going to be a little fast because this is not, I try to write my notes in very simple, terms so that you can always relate to it. That's why I always have long notes and all that. Okay, so my name is Bianca, and we're going to be looking at Unit 7 of Set 232, Integrated Science Special Methods, for this session. And we'll be looking at the place of the laboratory in integrated science teaching. The place of the laboratory in integrated science teaching. That is, of what use is the lab in integrated science teaching? What is it supposed to be for? Why do we need it? Do we need it? If we do, why do we need it? So here we'll be looking at four major, subsections. We'll be looking at the laboratory design. We'll be looking at organization and management of the lab. We'll be looking at safety in the lab, first aid in the lab, and then the lab assistant or technician. So I think I added other things, and we'll be looking at them as we go on. I'm very, very sure that we have seen a laboratory. It doesn't matter whether you saw it in your secondary school, but I know that right here in the university, we have a lab and you have taken lectures in it at one point or the other. And we believe as scientists that the laboratory is very important in the teaching and learning of integrated science. So integrated science is not just about acquiring scientific concepts and facts and knowing how to define things. And, it's also about developing the science process skills, the attitudes, the problem solving, abilities, the practical competence. It's not just about learning theories. Can you do things? Can you manipulate things? Can you carry out some simple experiments? So now that we are integrated science educators, what do we expect you to know as you move into the field, whether for your teaching practice or whether for your regular or your national youth service, and or as a regular classroom teacher at whatever level from kindergarten to tertiary. There are some skills that you should have, and we believe that the laboratory will provide you with the opportunities to gather those skills, observe phenomena, conduct experiments, test ideas, collect data, and even draw conclusions from evidence. So we need a well-designed and properly managed lab because it makes science teaching more practical, more meaningful. So the effectiveness of laboratory activities will depend on several factors, including design. I don't know if at any point in time you've ever thought that the design of your laboratory could affect the effectiveness of your activity in that lab. But now that I've mentioned it, I'm sure you are beginning to think about the lab we have that you have been in. Now you will begin to think, is it effective enough? So as we proceed in this unit, you are going to be seeing the good things about the lab that you know, and some challenges that are there, some things that you didn't think were challenges, but by the end of this class, you should, I believe you will know that there are challenges. Okay, so before I continue, I want to ask, can you still hear me?
Yes, we can hear you,
Please
ma.
mute yourself. Okay, thank you. Thank you so much. Please mute your microphones unless you have something to say, please, so you don't distract us. Thank you. All right, so there are some learning objectives. We won't spend so much time here. Let's go into the business of the day. What is a laboratory? What is a laboratory? We all know, we have seen it once or twice, maybe before coming into the university. Some of us that are not, we're not fortunate enough to, attend schools with these facilities, but at least I can say that in our department, we have one. So what is a laboratory? It is a specially designed room. Believe it or not, it is specially designed, okay? Where scientific activities, experiments, practicals, demonstrations, and all whatnot, other forms of scientific work are carried out. It is a specially designed room or facility where scientific investigations, experiments, demonstrations, and other forms of scientific work are carried out. Now, in integrated science teaching, the lab provides a link, between scientific knowledge and practical experience. In secondary schools in our climate, it is possible to find an integrated science laboratory, but more often than not, we have physics lab, we have biology lab, we have, sometimes some schools have the agric lab, then we have the chemistry lab, and then if the ITS teacher, by ITS, I mean integrated science, if the ITS teacher wants to, conduct any experiment, he or she will have to, borrow any of these other labs. It is not bad. It is okay. The most important thing is that you are carrying out scientific investigations and you are trying to provide a link between what you are teaching and practical experience. That is what the lab does. In fact, there is this saying that science without a laboratory is blind. Science without a lab is blind. What does that mean? You might want to think about it while we continue. So instead of telling students a particular principle exists, for example, instead of saying, if you put this in water, if you put oil in water, it is going to float. Oil is hydrophobic. You can actually demonstrate it in that laboratory. Now, the laboratory is usually a controlled environment So it is not, it does things do not go every which way. It is controlled. So instead of merely explaining, some concepts, you can actually show them things that sink, objects that sink in water, objects that float on water, the reason why oil and water do not mix, and so on and so forth. This is what your ITS lab is going to help you to achieve. Why is the laboratory important in integrated science teaching? Why is the laboratory important in integrated science teaching? Why is the lab important in science teaching generally? Very simple. It helps you to develop practical skills. But before I go further, could someone unmute yourself and tell me why you think the laboratory is important in integrated science teaching? I've already mentioned one. Helps us to develop practical skills. It is on your screen. I want more examples from you all. Why is the lab important? Let's go with Ogechukwu. Let's hear from you. Ogechukwu. Okay. Collins. We can't hear you. You're muted, but we can't hear you. Collins. The importance of the lab, the laboratory in integrated science teaching, or science teaching in general. Lucia. Lucia?
Lucia? Lucia?
Okay, so Lucia is not in the class, Ogechukwu is not here, and Collins is not here. Messi, are you here? Can you hear me? Class rep, can you still hear me? Okay, Collins says it helps us to carry out experiments. Okay. I need more.
It makes learning easier.
How does it make learning easier?
I would say if you say, for example, in chemistry, if you're saying that acid turns blue litmus paper to red. So for better
Yeah.
understanding, you will use the lab.
Okay. So that they can see it, right?
Yes, ma'am.
Okay, that's good. Franklin says it encourages teamwork. And Lucia says it provides students with the opportunity to acquire practical skill in their course of study. Yeah, Lucia copied what I have on the screen. Good one, Lucia. We see you. Judith says it promotes critical thinking and better understanding. That is correct. So the laboratory helps us develop practical skills. Some of those skills that we mentioned in, I think, 100 level or so. Measuring, observing, classifying, all those science process skills and all that, these skills are important components of scientific literacy. Nonya says labs are where theories become real. That's true. Lucia says it enhances curiosity and problem solving. I think you've all covered this. That's good. Thank you. Development of science process skills, reinforcement of scientific concepts. That's just what our friend just said. They help you understand what may otherwise appear abstract. If you tell somebody that one thing does one thing to litmus paper, the person will be looking at you, and during exam they will just put down the example the way you mentioned it in class, because they really do not understand what you said. It helps us to develop problem-solving skills. Yes. So it requires logical thinking, decision-making, and you have to follow things step by step. It encourages learner participation, just like Franklin says. It encourages, teamwork. That's also part of it. Now, laboratory work actually makes students to move from people that are just listening to you to people that are active. So it helps them to see, to touch, to manipulate, to measure. They are involved in what is happening. Imagine when you were in secondary school, your physics class, or that I'm assuming you had a lab then. You would agree with me that all those practical sessions were really nice. You having to do this thing, trace this one, draw this graph, find the intercept, and all those, they were really, nice. So I agree with you. Rejoice says it helps in scientific discoveries. That is true. Lovett says it helps us measure accurately. That is part of the practical skills. Thank you all very much. It helps us to develop interest in science. I like this one. Can someone explain this to us? Can someone explain this to us? The laboratory can help you, your student even, to develop interest in science. Let's hear from Odinaka Kosrep. Unmute your microphone and explain this to us. Don't read from my screen. Let me hide it. Where has she gone? Kosrep. Okay. Oluchukwu, are you here? Do you agree that the lab can encourage you to develop interest in science? If yes, please explain, give your reasons. If no, give your reasons too. Quickly. Oluchukwu, she's not here. Kamsi, are you here? Okay. Ibokwe, are you here? None of you are here. All right. Okay, I'm putting your names down. So, okay. Yes, please unmute yourself, unmute your microphone, and let me know. Yeah.
I think
Someone's hand
lab
is
helps
up.
yeah. Okay.
Yeah.
Lab helps students gain interest in science by through the performance of practicals. When the students see the abstract ideas they have been taught about in the class come to life in the lab, I think that
Yeah.
boosts their interest. I want to go further in science.
Yes. Does anyone disagree with him? Thank you, Daniel. Does anyone disagree with him? Okay. Yes, the laboratory can help you develop interest in science. Can the laboratory also make you not like science? Is that possible? Chike, is it possible for the laboratory to, make you not have interest in science? Unmute your microphone. Cynthia? Cynthia? Miracle? Miracle?
Yes, ma'am.
is it possible for the lab to make you not have interest in science?
Yes, yes, it's possible.
Okay, so tell us, give us a reason, an example, a possibility.
It can make someone dislike science, especially if the lab is stressful or safe.
That is correct. That is correct. I do remember someone who said she had to leave science. In fact, she decided to go into arts. She ended up becoming a lawyer though, so I don't think it was such a bad idea, but I don't know. She said one day during one of those acid bases and salts class, somehow the acid exploded. I think they poured something into something and they had this explosion. And please mute your microphone. Please mute your microphone. Thank you. All right, so there was an explosion in her lab when she was in JSS3. And since then, she said, no. She was going straight to arts, so she won't go and die. That was how she explained it. She's a lawyer though, so yes, the laboratory can, well-planned practical activities can make science very interesting, and enjoyable, and will encourage students to have positive, attitudes towards science and scientific careers. Yes, development of teamwork. Yes, Favor. Favor, do you have something to say? Favor, I saw your hand float across my screen right now. If you want to say something, you just unmute your microphone and say it. You don't expect me to keep reading from the charts. Okay. All right. So development of teamwork and communication. You know that most times in our secondary schools then, many of our lab activities were group works, group activities. So students learn how to cooperate, communicate their observations, work towards a common goal. In fact, if you create a group and just leave them, tell them, I want this thing done, so and so, do this and do that and do that. Those students in that group will come together and elect the person that will even present the findings to the class without your help. So they know their strengths, they know what someone can do, they learn to talk to each other, they share responsibilities, they communicate their observations, and then work towards a common goal. So, and if it is a competition, you're just going to hear them choose someone that will present their findings to the class, and then when the person is talking, they are cheering the person. This is what teamwork is all about, teamwork and communication, and lab activities helps us to build on that. Practical laboratory also helps us to develop safety consciousness. So when we look at some potential hazards in the lab, you're going to be looking at some of these safety issues. So when students participate in regular lab activities, they are going to develop responsible attitudes towards the handling of some equipment. For example, when you are in the physics lab and you are carrying out an experiment on electricity and all that, you already know the safety, the hazards, the precautions to take and all that. And then you transfer that safety consciousness out of the classroom, out of the lab, even to your homes, such that when you get to the house, you already know that, oh no, I shouldn't be doing this with an electrical equipment. It could electrocute me. I shouldn't do this with heat sources and all that. So somehow, when you are always exposed to a situation where you should be safety conscious, you find out that you transfer that safety consciousness outside of your classroom to your real life, scenarios. Again, the laboratory helps us connect science with everyday life. So there are some things that students investigate, like water purification. I remember in JSS3, we did separation techniques, how to use, alum to purify water. We did food testing, soil properties, energy transformation. That was where we did, conduction, convection, radiation, and all that. We also did simple electrical circuits and methods of separating mixtures. In fact, these methods of separating mixtures here taught me something. So when I was in JSS3, my ITS, what do we call him? Uncle. We used to call them sir. So my ITS uncle then used rice and beans to teach us separating mixtures. And he made us, pick he just gave us, we brought them from the house anyway, just little portions of rice and beans, and then we poured them together, mixed them together, and he told us to separate them. That thing, it gave me the patience that I needed to separate stone from beans. I'm not even joking. So anytime I'm expected to cook beans at home, that was in JSS3 then, I would just pretend that I'm separating mixtures in the classroom. So I transferred methods of separating mixtures from the classroom straight to my mother's kitchen. So all these examples, these are things that happen in real life that you can even do in your ITS lab for your students. And you'll find out that they are going to transfer such things, such knowledge from that lab straight to their own homes. Imagine teaching students water purification, boil water, then sieve it and all that. Imagine teaching them properties of soil, showing them which one is loamy soil, which one is clay soil, which one will your crops grow better in. Imagine teaching separating mixtures, just the way I was taught. And I started enjoying picking beans because I would pretend that I was separating mixtures. So these are some of the importance of practical activities, importance of having laboratory activities in your science classroom. It also helps you to assess practical competence. Now let's look at the laboratory design. This is just the planning and physical arrangement of a lab to ensure that it is safe, it is functional, it is accessible, and suitable for scientific activities. Laboratory design is the planning, it refers to the planning and physical arrangement of a laboratory to ensure that it is safe, it is functional, it is accessible, and suitable for scientific activities. A good integrated science laboratory should provide adequate space and appropriate facilities for everyone, including teachers and students, to carry out practical activities safely and effectively. Laboratory design refers to the planning and physical arrangement of a laboratory to ensure that it is safe, functional, accessible, and suitable for scientific activities. Now, what are the factors to consider in laboratory design? Let us say that let's assume that you are posted to a school and for some reason the principal decides to build a laboratory while you were there, or you propose that they should build an integrated science laboratory. And then the principal says, oh, you are in charge. You are in charge. Go ahead, take care of this situation. We'll provide the funds for it. What are the factors that you are going to consider while you are citing that laboratory? What type of design? First thing is the location. You should be thinking about the location. It should be located in a suitable part of the school where it can be easily accessible for both students and teachers. You cannot have your integrated science, your JSS class, in front of, close to the school gate, and then the lab is at the back of the school, and it will take students like 20 minutes to move from their classroom to the lab. No, it should be central. In fact, if you get to a school, most times you'll find out that all these laboratories are close together in the center of the school compound, where it is accessible to both junior students and senior students. So it should be located in a suitable part of the school. Again, it should have adequate space. It should have adequate space. While I'm mentioning these things, I want to be picturing the labs that you have been to, the laboratories that you have been to. Number one, is it central? The location, is it good? Number two, does it have adequate space? You should have enough space for students to move around safely. So the lab that you know, can you move around safely? It should have enough space for practical work, enough space for storage, demonstrations, even emergency movements. It should never be overcrowded. So overcrowding can increase the risk of accidents. So we've said that factors to consider in laboratory design: the location, space. The third one is ventilation. Ventilation. You need adequate ventilation, because most times experiments, involve chemicals or smoke, even unpleasant smells. So you need windows, vents, you need appropriate extraction systems. If you can picture your lab, you can, I know you can remember that you have very high windows in that laboratory. That is because we need ventilation in a lab. Now, the fourth thing you should consider is the lighting. The lab should have both natural and artificial lighting, so that students can read instructions, so that you can even identify equipment, so you can even see what you are doing, take accurate measurements. So whether there is electricity or not, there should be adequate natural light. We've mentioned location, we've mentioned space, ventilation, and lighting. The fifth one is water supply. You must have running water in your lab. You know what you need water for in the laboratory. You must have running water. There should be water. There should be sinks properly positioned. There should be water supply. There should be sinks everywhere, properly positioned. The next one is electricity. We've mentioned 6 of them now. Location, space, ventilation. What's the next one? Lighting, water supply, electricity. There should be electricity. So where you have electrical equipment, you should have safely installed electrical outlets. Not the lab you will enter and you'll be seeing wires everywhere. You should consider the fact that electricity should be here and adequately and safely installed. Properly maintained too. You can install safely and you don't maintain properly, and one day you will touch something and it's going to electrocute somebody or cause fires and all that. There should be work benches. You already know what that is. There should be work benches. So can you still hear me? Can you still see my screen? I want to be sure.
Yes.
Okay, thank you. All right, so we are talking about factors to consider in laboratory design. But before then, I said something about the laboratory design. What does it mean? What does the laboratory design refer to? What does it mean? Anyone? Quickly, we have a lot to do and it's almost 8 p.m. Quickly, please. Laboratory design, what does it mean? You don't need to give me my definition. Tell me what you understood. I'm waiting. I have 2 Messis here. So, Messi, what does a lab design mean? Tell me what you understood by it. Anyone?
Yes, to my own understanding, laboratory design means how lab is designed physically to ensure that it's suitable and is suitable for learners to make use of and is safe.
Thank you. We've also mentioned some factors to consider in laboratory design. Can you mention any one? Just give me like 2 or 3 or 10.
Okay, location, water supply, electricity, and ventilation.
Yes. Thank you. We also have lighting and then workbenches and then storage facilities. So you should have storage facilities for, storing chemicals, specimens, models, measuring instruments, and so on and so forth. There should also be safety facilities. There should also be safety facilities. So can you mention some of the safety facilities? You've been to laboratories before.
Fire
Let's mention some
extinguisher.
of the safety facilities. Yes, fire extinguisher.
Fire
Thank you.
extinguisher.
Yes, thank you. Mm-hmm.
Lab coat.
Yes, lab coat. Yes,
Safety
Daniel
boots.
says fume cupboard. Yeah, what did you say?
Safety boots. Safety boots.
Safety boots. What are you doing inside the lab with safety boots?
Safety glove.
Yes, yes. What about this first aid box?
First aid box. Yes.
Yes, yes. Macy James, you are correct. Lab design means the planning and arrangement of a lab so that it is safe, organized, and suitable for carrying out experiments and practical activities. Faustina says, is the way or manner in which the lab is built and arranged to maintain safety for students, not just safety, to make it organized, to make it suitable and functional. Yes, thank you so much. Now, apart from ventilation and all those things, there should be safety facilities, and you've mentioned almost all of them. First aid box, fire extinguisher, safety signs, PPE, that's protective, what again? Equipment, what's the P, the other P for? Can't think of it right now. Emergency washing facilities, emergency exits. So think of the lab that you know. Does it have an emergency exit? I don't know, but sand bucket, yes, that is correct. There should be teachers' demonstration area and accessibility. Now, when we talk about accessibility, in this case, when you are designing your laboratory, it should be accessible. Now, accessibility doesn't only mean being close to students or you can easily get to it. We are also talking about accessibility, for all learners, including students with disabilities. So where it is necessary, you should do some small, appropriate modifications so that you can, accommodate people that use, wheelchairs. You can accommodate people that use, what's that one? The walking stick and all that. That is why in some buildings, when you get to some buildings, you're going to find stairs and find another part beside the stairs. That place is for, people that use wheelchairs because of course, they cannot go up the stairs. So when we talk about accessibility now, we are talking about your laboratory being, accessible, being it should accommodate everyone. So if you have people with mobility issues, people that use walking aids, you should modify your laboratory to accommodate those people. If you have people that are visually impaired and for some reason they are in your classroom, you should find a way, to make it okay to a large extent for them. So sometimes we modify, benches, we modify pathways, staircases, entrances, even equipment, just to accommodate, everybody involved. All right, so before we go to organization and management of the laboratory, I want someone to quickly give me, two importance of the laboratory in teaching science. Two importance. Just unmute your microphone and give me two importance. Why do we need laboratories in science teaching? Quickly, so we can finish and you go and rest. Anyone, unmute your microphone.
We need lab in science teaching.
Yeah. Why? Give me two reasons. The importance of the laboratory in integrated science
To,
teaching.
to carry out experiments.
Experiments.
Yeah.
Another one.
I think it makes learning better for the learner.
You said?
Importance of lab
Yeah.
science is that it makes learning experiential for the learner. The learner
Yes,
gets to
very
see
correct. Next learning
and
experiential. Yes.
also
Yeah,
it helps the learner build scientific skills and attitude.
that is correct. Thank you. Now, when we say organization and management of the laboratory, what are we talking about? What are we talking about? We just want something that will save our time, something that will reduce wastage, something that honestly prevents accidents, something that will help you actually teach what you want to teach effectively. So we need to organize that laboratory. What does lab organization mean? It is just the systematic arrangement of the laboratory. Its equipment, the materials, the personnel, and the activities. Lab organization refers to the systematic arrangement of the laboratory, its equipment, materials, personnel, and activities. Systematic means, orderly. Lab organization is talking about the orderliness, the ordered way in which the laboratory, the equipment, the materials, the people involved, even the activities, how all these things are arranged. That is what we mean by laboratory organization. While laboratory management involves the planning, coordinating, supervising, maintaining, controlling, laboratory resources and activities. So while lab organization talks about systematic arrangement, the arrangement of the laboratory and everything inside it, including the people involved in the laboratory, both students, both teachers, both technicians and assistants and all that. Lab management involves planning, coordinating, supervising, everything that you do to ensure effective teaching and learning. Lab organization is talking about the systematic arrangement of the laboratory and everything in it, including everybody involved in it. When I say everybody, I mean both the teacher, the students, the lab technician, the assistant, and all that. While lab management involves planning, coordinating, supervising, all those things, almost like administrative duties, so to speak, that you will do to ensure that effective teaching and learning happens in that place. How do you organize lab equipment? First thing you should know is that it should be properly labeled, of course. It should be properly labeled. It should be stored according to their uses. Properly labeled, stored according to their uses, protected from damage. It should be regularly inspected. Now, you cannot come into a laboratory and there is this glass jar with something inside it, and it's not labeled. So you don't know the liquid that is inside that glass jar. That is already a problem on its own. Because what will you call it? How will you test that liquid to know what it is? So everything must be properly labeled. must be arranged systematically, must be stored according to their uses. Acids are usually locked away. Acids are usually locked away. All these things must be protected from damage. You don't just keep things haphazardly. They must be regularly inspected. In fact, that is one of the issues we have with laboratory management. Regular inspection. It must be regularly inspected, because you could find out that some of your equipment, for some of your chemicals, some of your equipment have expired, and you won't even know. And then one day you are called upon to do a practical, carry out one practical session, and you turn on the Bunsen burner and you have forgotten that the gas has finished. That doesn't show that you are in charge of that, laboratory. So frequently used equipment should be stored in locations that you can easily reach them. If you know that you are always teaching, maybe this week you are teaching separation techniques, and you know the equipment that you are using, they should be stored in a place where you can easily reach them. Not you teach on Monday and you know you are continuing that same concept on Thursday. You wash everything and lock them away, and then on Thursday you get into the class and you start scrambling to get them ready. No, they should be stored closer and where you can easily reach them. Again, materials like glassware, these are fragile and they are usually, of course, handled and stored carefully. Some of these things are things that you should be able to think of, but we are humans, so most times we need to be reminded. Fragile equipment are locked away, stored carefully. That is why you cannot walk into your lab and you will see all the glasswares on top of the benches. No, they are usually kept safely. Another thing I want to point out is heavy materials. In your lab, heavy materials are usually stored closer to the ground. So if you have a shelf, for instance, in your lab, all the heavy materials are on the down shelves, and then the lighter materials are up there. Lighter equipment, pipettes, all those ones that do not have weight are usually stored on top. But anything that is heavy are usually stored closer to the ground because, well, they are heavy. So if they want to break apart, they should break apart and stay close to the ground, not falling from up to down. So how do you organize lab equipment? They should be properly labeled, arranged systematically, stored according to their uses, regularly inspected, easily accessible when required, and so on and so forth. How do you store chemicals? Of course, the first thing, clearly labeled. Clearly labeled. How do you store chemicals? Clearly labeled, so that your student will not go and put hand inside acid. They must be clearly labeled. They must be properly sealed. They must be regularly inspected. They must be stored according to their properties. And when they are expired, please dispose of them properly. How do you organize chemicals? Clearly labeled, properly sealed, kept away from unauthorized persons before somebody will go and pour somebody HCl. Regularly inspected, and then when they are expired, please dispose of them properly. Remember, chemicals should never be stored in unlabeled containers. Chemicals should never be stored in unlabeled containers, please. I'm saying this whether you're going to be a teacher or not. You might be in a position where you are going to tell somebody this thing. Please, chemicals should never be stored in unlabeled containers. I wanted us to talk about lab inventory. These are some of the things that are not in this unit, but I feel that there's no way we will talk about the lab without mentioning some of these things. It is just a recording of everything that is in the laboratory. An inventory is a record of lab equipment, chemicals, materials, and other resources. Things that are available. It's like taking stock. Yes, exactly. Lab inventory is like taking stock. This one is available. This one is not available. This one is remaining small. This one is still filled. This one is damaged though. We have 5 pipettes are missing. This one has expired. We have new this. We have this. That is taking inventory. It's like taking stock. So what is available? What is still remaining? What has finished? What is remaining small? What is still plenty? Which one is damaged? Which one is missing? It's like taking stock of what you have in your shop. This time around, we are taking stock of everything inside the laboratory. Another thing about this lab inventory is that it should be regular. It should be regular, not once in a year. It should be regular, because you might find out that this chemical is going to expire in June, and then you do your stock in January, and you are seeing June. You're like, oh, that's good. It is still okay. And then next January, you come to take that stock. You find out that it has expired 6 months ago. And maybe around August, you are supposed to do something and find out that that thing did not work. Your litmus paper has expired. Your phenolphthalein is no longer working. You don't have gas again, or water has finished. No, you must do regular checks to tell the school what is available before practical lessons are planned. I just wanted to mention that part. So how do you maintain equipment? I'm not going to talk about this because I think it's part of the things that we'll be mentioning. How do you maintain this equipment? Cleaning, proper storage, calibration, lubrication, repairing damaged equipment, so on and so forth. I don't need to talk so much about that. Now, how do you prepare for practical lessons? How do you prepare for practical lessons? This is something that you may already know, but let's quickly talk about it. So before a practical lesson, you, the teacher, with your lab assistant, I'm assuming that you are going to have a laboratory assistant, which is what it's supposed to be. It is an ideal situation. But even if you do not have, you are the teacher and you are the laboratory assistant, that is not a problem. You should know that before a practical lesson, this is what you should do. You should identify the equipment and materials required. So if I want to carry out a practical session for this course, I am going to write out the things that I need and give to our lab technician. I'm sure you have met her. I will take it, give to the lab technician, and we will talk about it. She is going to be the one to look at her stock, her inventory, identify the equipment, identify the materials that are required. Are they available? Are they okay? If we need, chemicals, she's going to prepare those chemicals. If we need to do if we need some kind of specimen, maybe onion or whatever it is that we want to do, she's the one that is going to provide those specimens. She will arrange the apparatus. She's going to review the safety precautions. She's going to make sure that your emergency facilities are accessible. And then she's also the one that will organize you people in appropriate groups. The job of your job, first of all, as a teacher, is to say, this is what I will be needing for my practical class next week, Monday. Your lab assistant or the lab technician, whoever it is that is in charge of the laboratory, or maybe you, anyway, if you don't have all those, if you don't have an assistant, your job is to identify the equipment and the materials that are required, check that they are available, test the equipment where necessary, prepare the chemicals, arrange apparatus, everything that you need to do. This is going to help you to, prevent and reduce unnecessary delays during practical lessons. That is the job of a teacher and a laboratory assistant. There are rules in the lab. There are rules in the lab. I'm not going to mention them. You should know them. You don't test chemicals. You don't eat or drink in the lab. You only enter the lab when the teacher permits you. You don't run. You don't push in the lab. You don't inhale chemicals directly just open it and put in your nose and inhale it to know what it is. You don't do that. You must always wear your protective equipment. Report anything that you break, report it. Do not use any equipment without appropriate instruction. Now, when you get to our lab, you're going to see this very large white banner in the lab. As soon as you open the door, it's right there in front of you. Those are the laboratory rules that we have in our integrated science laboratory. So maybe when you get to school tomorrow, you get to the lab and look at, just open the door, and the first thing in front of you, behind the shelf where we have that skeleton, you're going to see this very large white banner with laboratory rules. You must have them in your lab. You must have them in your lab. Let's quickly look at safety in the lab. Before then, do we have any questions so far? I used, simple terms so that we can always, understand what we are talking about. Do you have any questions so far, please? You can unmute yourself and ask. Any questions? If you don't have any question, okay. Can someone tell me what a lab inventory is? Tell me what a lab inventory is, and tell me one or two things that you'll be checking in that inventory. Isn't it? Isn't it? What is a laboratory inventory? Charity. Ifunanya. Odinaka. Can anyone still hear me? Is anyone in the room? Am I the only one here?
My
No,
lab
we are not the only one.
inventory. Lab
Okay,
inventory is
so
a regular record of the equipment or materials in the lab.
yes. When you want to take inventory, tell me one or two things that you will be looking out for.
Hi.
Looking out for the expiring dates and the worn out materials in the lab.
Yes. Oh, yes. That is awesome. Thank you so much. Okay, so we will just be, I just want to mention what safety in the laboratory is all about. And we'll quickly go on to something else because, well, everyone is tired. All right. This safety in the lab, we know what safety is. Okay, so laboratory safety refers to the practices and procedures that are designed to prevent accidents, damage to equipment, exposure to harmful substances during lab activities. Safety in the laboratory. Lab safety refers to those things that you do, those procedures that you take, those practices that you design, to prevent accidents, injuries, damage to equipment, and even exposure to harmful substances during lab activities. So as an integrated science teacher in your ITS lab, what is lab safety? Anything that you do in that lab to make sure that there are no accidents, your equipment are not damaged, and students are not exposed to harmful substances during your practical activities. That is what we mean by laboratory safety. And it is very important in every practical lesson. In fact, that is why it is advised that you have your lab rules in your lab where everyone can see it, both the teacher and the students. At every point in time, they must see your lab rules, because most times the lab rules help you to prevent, some accidents. Like when you tell people do not inhale chemicals, it is there in the rules, and you keep reiterating that fact. You keep mentioning it. Don't do this, don't do that, don't do that. I remember when I was in SS1, our biology teacher, every time we enter the lab, we read our rules. We had about 30 rules on the wall. So as soon as you enter, the first thing we do is everybody, you read your the rules from number 1 to number 30. I think it was more than 30 or 35. When you are done, you will sit down before she starts teaching and setting out the things that we need. So it is her own form of maintaining laboratory safety. And the more you keep talking about these things, don't do this, don't do that, don't do that, it keeps, it sticks in the mind and brains of your students and anyone that is using the lab. So safety is a very important part of every practical lesson. Believe me, you will not like it if a student comes into your class and drinks hydrochloric acid. You will not like it. Now, even if you don't become a teacher, believe me, you will not like it if your child returns from school or they call you from your child's school to tell you that she fell down. She fell in the lab and someone had already broken some glass jar or a beaker, and your child falls, maybe slips and fell on top of the glass. You will not like it. It is not a good thing for anybody to hear. But so we must pay attention to these things. There are some common, hazards that happen in the lab. We classify them usually, I think, into 4. We have the chemical hazards, the physical hazards, electrical, fire, then, okay, biological. Yeah, that's when we talk about biological materials. Okay, now, the common lab hazards, we usually talk about 4 of them, but now we talk about 5. The first one is the chemical hazards. Chemical hazards are, any form of problem that will arise because of a chemical. They may result from, poisonous chemicals, flammable substances, inappropriate chemical storage. Any hazard, any problem that will arise as a result of exposure to chemicals is what we call chemical hazards. There are physical hazards. Physical hazards can be, as a result of broken glass, sharp objects, slippery floors. Someone has spilled water on the floor and didn't bother to clean it up, and then someone slips on the floor and falls. It's a physical hazard, and it is not nice because, yeah, well, it is a lab. You could fall on top of something that could, seriously injure you or the students. So, chemical hazards. These result from corrosive substances. I hope you know what corrosive means. Something that you can touch and it will peel off your skin or damage your skin. That's corrosive. Usually acidic. Toxic chemicals. Flammable substances. These are substances that can catch fire. These are chemical hazards. Physical hazards include broken glass, sharp objects, hot surfaces. Your student touching the surface of your gas cooker or your Bunsen burner, falling equipment and all that, overcrowded workspaces. We have electrical hazards too. I'm rushing over these things because they are in plain English, of course. We've talked about it, I think, sometime in your 100 level. Electrical hazards may result from exposed wires. I mentioned this earlier. Exposed wires, faulty electrical equipment, wet hands, touching the sockets, touching some of these connections with wet hands, overloaded sockets. Those of you that come into the lab to charge everything in your hostel. Oh God, overloaded sockets can cause, I don't know why Lovett is laughing, I don't say anything. But when you come from the hostel with everything, just to find space in the lab to plug them, you have overloaded the socket. Oh. If any small thing happens, now fire. Oh. You also have fire hazards. Fire hazards can come from, naked flames, faulty electrical equipment, careless handling of heat sources, and so on and so forth. So when we ask you to mention common laboratory hazards according, let's say, give chemical hazards, physical hazards, electrical hazards, fire hazards. You should be able to know how they, how we can expose ourselves to these things. How can you expose yourself to fire hazard when you have naked flames in your lab, when you have chemicals that are flammable, faulty electrical equipment, improper chemical storage? You will carry your chemical and face it, keep it near your window. On a very sunny day, whatever you see is what you take. Careless handling of heat sources. You have finished with the Bunsen burner. You have finished with the your gas cylinder, your gas top, or your gas stove, or your gas cooker. Put them away. You will leave it there, and somebody's child will go and touch it. You will not like yourself in jail. Jail is not a very nice place to stay in. And even if you are not the teacher involved, and it happens to your own child, you will take it up with the school. So these are hazards that you must, to the best of your ability, prevent from happening. We also have what we call the biological hazards. When you have contaminated specimens, microorganisms. So these ones sometimes do not apply to those of us in ITS, but you never can tell. You're not ending in ITS. You can be posted to a school and you're expected to teach biology, and then you have all those specimens in glass jars, and then they are contaminated. Or you ask students to bring earthworm or some kind of worm, and you're allowing them to touch them without wearing gloves. You're exposing them to some hazards, contamination, contaminated specimens, and all that. So there are hazards, and we've classified them into five categories: the chemical hazards, the physical hazards, electrical hazards, fire hazards, and biological hazards. Now, this is what you are going to do. When you have some chance, I want you to look up maybe on the internet and find some symbols. It just came to me. There are symbols, some diagrams, okay, they are called symbols, that you can see, and you will know that this thing is some kind of hazard. This is avoid this thing. We have so many of them, so look them up. Symbols used to represent some of these hazards. Symbols. So there are general lab safety precautions. So it's practically what we have just been saying. Oh, the PPE I was talking about is actually personal protective equipment. I keep forgetting what the first P means. Personal protective equipment. That's where you have the lab coats, the safety goggles, the gloves, the footwear. That person that mentioned the rain boots or boots, masks, face shields, and all that. These are personal protective equipment. So but it depends on the activity that you are carrying out, okay, and the hazards that are involved. All right, so I added first aid. But I want us to quickly look at the first aid box. First of all, what is first aid? It is the immediate assistance. You see, this sentence is very important. First aid is the immediate assistance given to a person who has become injured or becomes ill before professional care is available.
I'll go back, Baka.
Charity, do you have a question?
No, I don't have a question, ma.
Okay, please mute your microphone. So first aid refers to the immediate assistance. Charity, mute your microphone. I don't want to hear what is happening in the background. Thank you. It is the immediate assistance. That assistance that you give somebody immediately something happens before professional medical care is available. That is first aid. Immediate assistance given to a person who has become injured before professional medical care is available. You must always have a properly stocked and accessible first aid box in your lab. A properly stocked and accessible first aid box in your lab. I've also written out some common lab accidents. I'll probably send this to you. Some common lab accidents and their basic first aid. Your students can have a minor cut from a broken glass. What do you do? Move the person away from the hazard. You can even wash the hand if it's on the hand, clean the wound, cover it with a sterile dressing, and then call for your what do they call your nursing station to come over. Burns. So these are some of the chemical hazards, some kind of first aid that you can give. So I'll probably send this to you, but I need you to pay attention to them. As a teacher, what are the common laboratory accidents and basic first aid that you can give? The first one I have on my list is minor cuts from broken glass. The first thing you do is take the person away from that place that the thing broke. Okay? Wash the wound because you should have water supply. We've mentioned that. Cover it with a sterile dressing. Sterile dressing could be whatever you have in your first aid box, like the cotton wool and plaster, and then call the nurse in your school. Seek medical attention. So some schools have nursing stations. So you can call them, especially if the wound is very deep. Don't use your bare hand to pick up the glass, the broken glass. You don't do that. Another one I have is burns. Someone has touched your gas stove. Remove the person from the source of heat. Put cold water. If you have running water, which you should, put the person's, the affected area under water and then call the nurse. Don't go and start rubbing something there. You are not a nurse. Put water, cold water. If you have ice, put ice there and then call the nurse to come and give proper medical attention. Remember that first aid is just immediate assistance before professional medical care comes. The first thing you do, let's say if it is a cut from a broken glass, clean the wound, cover it with a sterile dressing, and then call your nurse, seek medical attention. If it is burns, maybe the child has touched a hot surface, cool the place with cold water or running water, and then call the nurse. If it is a chemical splash on the skin, quickly remove the contaminated clothing where appropriate. You have to wash the place very well with running water first. So I'm going to send this to you so that you will look at them and prepare yourself. So there are lots of them. I'm also going to expect you to know what you should have in your first aid box. What you should have in your first aid box. You did this in secondary school, you did it in 100 level, so it's just basic knowledge. What should you have in your first aid box? Sterile gauze, adhesive dressings, there are so many of them, paracetamol, scissors, and so on and so forth. You should know them. What you should have in your first aid box. Remember that there are other hazards. Remember that there is something called first aid in the laboratory, which is the immediate assistance that you are giving to somebody before a professional medical care comes. Okay? And then there are common lab accidents. It could be burn, it could be minor cuts, it could be chemical splash, it could be chemical splash in the eyes. Is an emergency. It's an emergency. Electric shock is an emergency. Remember that when someone is being electrocuted, please do not touch the person. Please do not touch the person. Just go and quickly switch off the electrical supply. This one is no longer about practical, even in your own house. If someone is being electrocuted, do not touch the person while they are still connected to that electrical source, or else both of you will jam each other, or you will gum there. Just quickly go and turn off the electrical supply and then seek emergency medical care. The first aid box, what should be inside it? I expect you to know what should be inside your first aid box. All right, so the last thing we should be looking at is the lab assistant. Duties of a lab assistant. We have mentioned it earlier. If you were, taking notes, when we talked about what the lab assistant and the teacher should be doing. Duties of a lab assistant or a technician. What should you be doing if you become a lab assistant somewhere? Your job is to prepare materials. Your job is to set up experiments, maintain equipment, store the equipment properly, manage. We have mentioned this thing earlier. Take your inventory, that is maintaining records, safety support, clean and maintain your laboratory space. It is your job. Support practical lessons. Report problems. This one is very important. You must report problems. This one has spoiled. This one is not working. This one is overworking. This one has become a safety hazard. This one is malfunctioning. We don't have enough of this, or we have too much of this. Let's find somewhere to store them. What is the job of a laboratory assistant or a lab technician? All right, so we're going to be stopping here so that we don't overload our brains. We have talked about laboratory design. We said that the laboratory actually is a specially designed room. It is specially designed. A specially designed room or facility where scientific investigations, experiments, practical activities, demonstrations, and other forms of scientific work are carried out. We mentioned that instead of talking about things that could be abstract, things that students cannot actually imagine in their minds, we use the laboratory to bring that thing closer for them to understand what it is exactly you're talking about. So the laboratory provides a link between scientific knowledge and practical experience. We mentioned some importance of the lab in integrated science teaching. We talked about the laboratory helping us to develop practical skills, develop science process skills, help us to understand concepts that appear abstract, help us to develop problem-solving skills. It encourages learner participation. Now, students are no longer just sitting down and listening to you. They are now active participants in the learning process. It helps people to, children to develop interest in science, not just children, anyone develop interest in science, especially when it is well planned. So it becomes interesting and enjoyable. It also leads to, development of teamwork and communication. Laboratory activities usually happen in groups. So students now learn how to cooperate, how to share responsibilities, how to talk, how to communicate their observations, and how to work towards, achieving a common goal. We also said that laboratory activities also help us to develop safety consciousness. And we mentioned some of the hazards that can happen in the lab. Now, you know that you should not touch naked wires. So when they say it in the lab, you get to your homes and you don't touch electrical wires because you're already used to being safety conscious around electrical wires. Again, the laboratory helps us connect science with everyday life. I mentioned some of the So I mentioned some of the practical activities that can happen in your integrated science lab and how it helps students to connect them in real life. I mentioned how my teacher taught us separating mixtures and used the rice and beans and asked us to be picking separate the rice from the beans. The thing now helped me to have patience when I'm picking beans in my mother's kitchen. I'll pretend I am separating mixtures. We also mentioned the laboratory design, and we say it is, the planning and physical arrangement of a lab to ensure that it is safe, it is functional, it is accessible, and suitable for scientific activities. We mentioned some factors to consider. Some factors to consider in lab design. Location. It must be in the part of the school where anybody can reach it. Adequate space. It must have enough space for people to walk around, to store equipment, to prepare materials, for practical work. It should not be so tiny. Ventilation. We must have enough ventilation. Windows, fans, vents, all these things are necessary in the lab. Lighting. You must have natural lighting. You cannot situate your lab in the part of the school that is always dark, so that whether you have electricity, artificial lighting, that's electricity or not, there should be the lab should be bright enough for people to read instructions, observe experiments, and so on and so forth. The fifth one is you should have water. There should be water. You should have electricity. You should have workbenches. Workbenches, not some labs that you will get to and you will just see the teacher's table and seat and chair. You should have storage facilities. So you should have where you are storing your skeleton, your specimen, your glassware, measuring instruments, and so on and so forth. You should have safety facilities. First aid box, fire extinguisher, emergency exits, safety signs and symbols, and so on. And then I said the laboratory should be accessible to all learners, including students with disabilities. So when you are designing a lab, you must think about students that cannot, that have mobility issues, or students that have, visual impairment issues. If for some reason you have them in your classroom, you should make provisions for them. We also quickly looked at organization and management of the laboratory. And we said it is the systematic arrangement of the lab and everything inside it. While laboratory management involves planning, coordinating, supervising, maintaining, all those administrative things that you do to ensure effective teaching and learning. I need you to know the difference between lab organization and lab management. How do you organize lab equipment? We have talked about it, and we said it must be properly labeled. It must be stored properly, protected from damage, regularly inspected. That is how you organize your lab equipment. How do you organize chemicals? Clearly labeled, properly sealed, regularly inspected. These are things that you must always remember. Chemicals must never be stored in unlabeled containers. We also talked about the laboratory inventory, and we said it's just, like taking stock in your shop. So it is a record of everything in your lab, from equipment to chemicals to materials, even books and pens. So it should always show the items that are available, the quantities available, the condition of the equipment. Is it damaged? The ones that are missing, the ones that should be replaced, and the ones that are new. In fact, it should even have the ones that are too much, so that you will tell them to give you another space so that you can pack them or give them out to other schools if there are things that can, expire. How do you maintain equipment? You already know that. Proper storage, repair the ones that have damaged and all that. How do you prepare for practical lessons? This is also the duty of the lab assistant. Before a practical lesson, the teacher and the lab assistant should identify the equipment, check the ones that are available, test the ones that you should test, prepare chemicals and specimens, arrange the apparatus, review safety precautions, and so on and so forth. We talked about lab rules, safety in the lab, things that you do to prevent accidents, injuries, damage, even exposure to harmful substances. We talked about common laboratory hazards. Remember, common laboratory hazards. We mentioned chemical hazards, physical hazards, electrical hazards, fire hazards, biological hazards. I want you to remember the examples of each one under this. And I said, please go on the internet and find the symbols for each of these hazards. Symbols for each of these hazards. And then the last one we talked about is first aid. First aid in the laboratory. What is first aid? Immediate assistance that you give to a person who has been injured before professional medical care arrives. We talked about the common lab accidents and their basic first aid. We talked about minor cuts from broken glass, burns. You know, the good thing about this is that after learning it, it's not just about your practical sessions. You can apply them in your home. If you mistakenly touch your gas stop and it burns your hand, what do? You put your hand in cold water. If it is too bad, you start going to the hospital. If a glass cuts you, if you get a broken glass cuts you in your kitchen, what is the first thing you do? You wash the place. If it is deep enough or it is still bleeding, you cover it with something that is clean. If it's in your lab, you should have cotton wool and plaster, cover it with a sterile dressing and start going to the hospital. If it's a chemical that's splashed on your skin, the first thing you will do is to wash it with plenty of water. If it is on your body, God forbid, you remove the contaminated clothing and start going to the hospital. If it is chemical that's splashed in your eye, it's an emergency. Plenty of water to wash the eye, rush to the hospital. If it is someone that has inhaled harmful substance, take the person outside to fresh air immediately and call for medical assistance. If it is electric shock, don't touch the person. Switch off the electrical supply, call for medical assistance. We talked about the first aid box, and I said you should know the basic supplies that you should have in your first aid box. The lab assistant or technician, we already mentioned the duties of the lab technician. We mentioned them earlier. They prepare materials, set up experiments, maintain the equipment, take inventory, they store the equipment, support for safety, and even support, practical lessons. They report problems. All right, so we're going to end it here. The unit doesn't have so much of this, but I decided to add them so that we can know them. It's not always about passing exams. It's about knowing something that you should know. That's why I added a lot of this, and that's why it took a lot of our time. So do you have any questions? Do you have any questions? Let's speak. Yes?
No, ma. No, ma.
Okay.
Ma, please, can we get the note on the course on this
Can I
topic?
hear you? I didn't hear you.
Note for the topic. Can you send us the note?
I will think about it. I will think about it. I'll probably give you the notes, or I will send you the recording of this class. Any other question? Okay, so remember to look up the symbols for those hazards. I need you to know those hazards and their examples. I need you to know what you should have in your first aid box. I need you to know the duties of a lab technician, a lab assistant. I need you to know what lab inventory is and what you should have in your lab inventory notebook. I need you to know what you need to consider when you want to design a laboratory. All right, so In the absence of questions, if you do not have questions, I'm going to let you go now so that you can rest and think about this. If the note will be coming out, I will send it across to your course rep, and I'll probably send the recording to your course rep so that you can revisit it over and over again. All right, so I think we are done, and I can safely say thank you for being here and have a good evening. Thank you.
I'll mute your mic.